Okay, so we are going to use trigonometry to help us find either the apothem or the information we need to find the perimeter. And then at the end, we're going to plug those numbers in for A and P, multiply it by 1/2, and find the area. So, Max, what shape is this in example 1? I'm trying to trick you by writing it right in front of it. Yeah, it's a pentagon. Sometimes when it's too good to be true, you get nervous, right? So a pentagon has a side of 6 centimeters. Given this information over here, Clay, come right where the side of 6 goes on our pentagon. Where does 6 belong? Put a 6 where the 6 goes on our pentagon. So the 6 is our side length. Thank you. And then, sorry, Clay, you get double because I've already played row bingo with your row. So I don't remember getting Jesse. Jesse's my last one. I should have picked Jesse instead of Clay. You're welcome. You get twice the fun. Okay. So we are missing the, Jesse, can we find the perimeter given the 6 right here? Okay, so let's go ahead and do that. So the perimeter is what? 30. Yay, half of my problem is done. I've already got the perimeter. Now we just need to find the apothem. Okay, so let's put our center. It's like we're finding its belly button. So they give them this little belly button right there. We are going to draw a line from the center perpendicular to the side. It technically cuts the side in half. So in this case, I get 2 sides that are, if you split the side in half, you get a 3 and a 3. And I want the apothem. Well, diabolically, trigonometry includes an angle. So we're going to have to use some math to find the angle. So if I'm going back to Claire, how many degrees are in a full circle? 360. There are 360 degrees. And Sebastian, the pentagon has how many sides?
5.
5. And what is 360 degrees divided by 5?
That's a good question for you.
Got a calculator right in front of you.
72.
You're messing with me. You're messing with me.
72.
I know, but it's for Sebastian.
72.
72. So this angle from our center that touches our vertice to the next vertice is 72. But my apothem cuts that guy in half. So, Jack, what is half of 72?
36.
Half of 72. 36. So this angle up top is 36 degrees. So I've just taken this little triangle here and I've separated him because sometimes it gets crazy mixed up inside. Here's our apothem. Here is our 3, since we split that side in half. And I need to use trigonometry, so let's go ahead and label it. So your options, Andrew, are opposite, adjacent, or hypotenuse. What is the apothem to 36? Opposite, adjacent, or hypotenuse? Adjacent. And then Damien, we only have opposite or hypotenuse left. What is 3 in comparison to 36 degrees? Opposite. Okay, remembering from chapter 8 itself,
And
which trig function uses adjacent and opposite?
and
Huh? The opposite and adjacent? TOA, yeah. So it's tan. So some of you guys forgot this for the midterm, so we're just going to review it. So the tangent of 36 degrees is equal to the opposite side over the adjacent side. We usually put the tangent, when we are cross multiplying, and we are definitely going to have to cross multiply here, we put the tangent of 36 degrees. Some of you guys like to separate, for some reason, tangent from the 36. Tangent is the same thing as like a square root. It's an operation. You can't just go, all of a sudden they're not together anymore. Once we tan 36, it's stuck to that 36 until the bitter end. This is what we're going to be putting in our calculator. Okay, so we're going to cross multiply. A times the tangent of 36 degrees is equal to 3 times 1. To solve for A, which is the apothem, we're going to divide both sides by tan of 36 degrees. When we do that, let me show you how I have this calculator here. This calculator here likes the angle first and then the trig function. So we're going to go 3 divided by tangent of 36. This one likes the 36 and then tan. And a equal sign gives us 4.1. So the apothem is 4.1. Make sure you guys can do that on your calculators. Okay, so we're going to come back to our equation. Area is equal of a regular polygon is equal to 1/2 app. So that is 1/2 times the apothem we got was approximately 4.1 centimeters times the perimeter, which we calculated at the beginning, was 30. So that is 0.5 times, take it away from it, nope, it's stuck to it. 4.1 times 30. So we have an area of 61.5 centimeters squared. So circle that, and we'll give it a star because there's so much going on. So just to backtrack, we had to find the perimeter, knowing that each side was 6. We had to use trig, so we split the 6 up into 3 and 3, so that we can use trig to find our apothem. Once we found our apothem, we plugged it back into the formula. Octagon. All right, Krista, how many sides does an octagon have? 8 sides. These are my tentacles. There. 8 sides running around. Okay, so it's got 8 sides. All right, so if a circle starts out with 360 degrees, and we got to divvy that up into 8 different pieces. Jacob, what's our angle measure for one of those 8 pieces? 45. Oh, wouldn't it be nice if it were a 45, 45, 90, but does this even look close to 90 degrees?
yes.
This doesn't look close, it's a cube. It's not anywhere near 90 degrees, unfortunately, and it has to be the same. These 2 angles here have to be the same, so it's not. It's not going to be a 45, 45, 90 here. But that's okay, because we can deal with it. We got our mature pants on. Okay, so Our central angle is 45 degrees. And Danny, come and put the radius of 8 inches on this picture. Put the 8 where it goes. Where does the 8 go?
Danny, where's the 8 go?
Where does the 8 go?
You.
Quarter. Goes to the corner.
Goes to the corner?
The radius goes from center to the corner. The apothem goes from center to the side.
Alright, today, Danny.
Awesome.
Jacob?
So the radius is 8 inches. It is actually from the center to the corner. So we can say that this one is also 8 inches. So we need to put together a trig. Unfortunately, this is not a right triangle as we've been discussing further. So let's put the apothem in. It's going to be this blue line. We're going to call it A. And I'm going to take that little triangle and move it off to the sides. The apothem is here. The whole thing was 45 degrees, but we need half of that. Stevie, what's half of 45 degrees? 22.5. So our angle at that top is 22.5, and we have this 8 inches here as our hypotenuse. Okay, so let's go ahead and write our area formula. A equals 1/2 at. And Miss Lexi, I gave, well, you can, it's okay. I already gave you what A is, but, okay, so your choices are opposite, adjacent, or hypotenuse. What is the apothem, or side A, compared to 22.5? Is it the opposite, adjacent, or hypotenuse? Adjacent. We're going to go ahead and write that on our picture. And what's 8? Opposite, adjacent, or hypotenuse. Okay, so Nick, what trig operation uses adjacent and hypotenuse? Cosine. So we're going to go cosine 22.5 degrees equals adjacent over hypotenuse. Cosine of 22.5 degrees equals adjacent over hypotenuse. We put the cosine of 22.5 over 1 and cross multiply. So 8 times the cosine 22.5 is equal to A times 1. Yay, and we'll have our apothem. So let's go 8 times cosine of 22.5 equals 7.39. So A is approximately equal to 7.4. Great. So we're back to Peter. So Peter, what things do we need to fill in this area formula? We got that. We need the perimeter. Okay, unfortunately, we have the radius and not the side. So, we need to trig one more time to find the side. And in fact, we're not going to be given the side. We're only going to, when we trig, we're going to find half of the side. We're going to have to double it to find the whole side. So, I'm going to redraw this triangle. So right now we're going for perimeter. To get to the perimeter, we got to find the side. To get to the side, we're going to find half the side first. So once we find the half the side, we'll double it to find the side, and then we'll multiply it by 8 to find the perimeter. So it's going to be a 3-step. So let me redraw this little triangle. My students yesterday asked if they could just please use Pythagorean theorem. And I said, yeah, that would be fine, except we rounded this. So if I rounded this, I don't want to use this in calculations because it's a rounded number. So I'm going to go back to trig because 22.5 is not rounded. That's legitimately half of 45. So we're going to go back to this, and we're going to say we want to find this little base right here. And we know that our side is equal to 8. Thankfully, I know 8 is the hypotenuse. So chi, adjacent or opposite, what's B? Opposite. And then Justin, which trig function uses opposite and hypotenuse? Sine?
Sine.
Yeah. So the sine of 22.5 degrees is opposite over the hypotenuse. We're going to do the same process as we did here. Put it over 1. Cross multiply. 8 times the sine 22.5 equals B. Calculator to the rescue. Side note, when I was a young student like y'all, we got a table. It was a table in the back of the book, and you had to look up sine 22.5. Had like a bunch of trigonometry listed. You had to go look it up in the back of the book, and then multiply it by 8 by hand, and then find the answer. So, welcome, calculators and technology. Lucky you guys. So we got 8 times the sine of 22.5 is 3.1, and that's, of course, approximately. And that's inches. Okay, so B is approximately 3.1 inches. That's half of the side. So what's a whole side? This is like 3.1 right there. So a whole side is going to be double that. It's going to be 6.2. So the whole side is 6.2. Merck, help us out. Can you help us find the perimeter of an octagon when one side is 6.2? Maybe. It's 73.6. So the perimeter is 73.6 inches. Now, I have everything for this formula. I have got the apothem, which it seems like 9 years ago we figured out was 7.4. And we have the perimeter, which we figured out was 73.6. So we are going to, once again, calculator to the rescue. 0.5 times 7.4.
It's 40. That's not the perimeter. Yeah. It's 49.6.
49.6. Thank you. Before we committed to putting that in the calculator.
Yeah, I could make that.
So it's 8. 8 times 6 is 48. Okay, yeah.
6, thank you. 49.
Gotcha. Thank you. 49.
How does that work if there's two sides that are different? There's two sides that are longer than every other side. Oh.
Okay, so that's 3.7 times 49.6. 183.52. So we're going to round to 183.5. Square inches. Ew. Okay. Okay, so we got two more. So we want to find the area of a regular decagon. So think about this. How many years are in a decade? 10. So a decagon has 10 sides. It's the DEC. Means 10. So we're going to take 360. This is an easy calculation. Divide it by 10. Our central angle is 36 degrees. It tells us the apothem. Yay! Because when we're using the formula A equals 1/2 ap, we already have the apothem. That's one less thing we have to solve for. So the apothem, they say, is 14. This is the first time they've given us the apothem in these practice problems, so yay. 14. And so let's pull out our little triangle. Apothem is 14. Half of 36 is 18. To find the perimeter, we need to find this little base right here. So we got opposite and adjacent, and that is tan. Tan of 18 degrees is opposite over adjacent. Oh, and this is even super sweet. It's going to be 14 times tangent of 18 equals B. That is all just a calculator. Equals 4.5 if we're rounding to the nearest 10. But remember, that is half of this side. So to make a whole side, we need to times it by 2. So that's about equal to 9.0. And easy math, 9 times 10 sides. Is equal to 90 centimeters. So now we're ready for the formula. A equals 1/2 ap. The apothem they gave us was 14. The perimeter they gave us was 90. Half of 14 is 7. 7 times 9 is 63. We just tack the 0 on the end, and that's centimeters squared. So we like it when they give you the apothem. So when you get the apothem, it's like, yay, Christmas, the apothem came. Here it is. All right, let's cut to the chase. Equilateral triangle. What are all three angles when we have an equilateral triangle? They're the same and they're equal to which number? 60. We have 180 altogether in a triangle, and each of those is 60. Then you're trying to find the area of an equilateral triangle. We're still going to use 1/2 ap. The apothem goes from the center of your triangle straight down, makes a 90-degree angle. The line, which is the radius from your center to your corner, cuts this 60 degrees in half. Half of 60. 30. So let me draw that little triangle for you here, a little bit bigger. This guy is half of 60. This guy is 90. What does this one have to be? If one's 30, one's 90, the other one has to be 60. Thankfully, we like the 30, 60, 90 triangles. 30, 60, 90 triangles have special property. That's why they're called a special right triangle. Our side length, our little side is here. Our hypotenuse is double our side length. And our medium side is our side length times root 3. Okay, so there, we know that the radius is 6. That's this distance right here. I'm going to transfer that to there. So short side, hypotenuse, or longer side, what did they give us on this 30, 60, 90 triangle? The hypotenuse, the short side, or the longer side? They gave us the hypotenuse. So we know the hypotenuse is double the short side. So what does our short side have to be? Has to be 3. And we're going to need that long side to find the perimeter. So we're going to go the short side times root 3. So this is 3 root 3 from here to here. Okay, we need the perimeter. So this is only half of our side length. What do we get when we double 3 root 3? We get 6 root 3s. How many sides does the triangle have? 3. So we need to multiply this by 3 to find the perimeter. 6 times 3 is 18. So the perimeter is 18 root 3. Now I have everything I need for this formula. The apothem is 3. The perimeter is 18 root 3. I don't want to multiply 1.5 by 18, so I'm going to take half of 18 first. Half of 18 is 9. 9 times 3 is 27, and 4 root 3 just stays. So the area is 27 root 3 centimeters squared. All right, we did it, guys. We did it. Now we're going to have